Hello LANDAU students, I am Miss Sara, and I would like to thank you for joining me to discover our amazing Earth through geography. The theme of this lesson is earthquakes. Please pause the video to draw the graphics, take notes, and search for any words that you may not understand. As we first take a look at earthquakes, it is important to understand that earthquakes are found all over the world and impact people in different ways. We will learn about the different kinds of earthquakes and their causes. After learning about the different kinds of earthquakes, we will take a look at one of the most famous faults on the planet, the San Andreas Fault. And in looking at this fault, we will look at an earthquake that happened there in 1906. An earthquake is what happens when two blocks of the earth suddenly slip past one another. The surface where they slip is called the fault or fault plane. The location below the Earth's surface where the earthquake starts is called the hypocenter, and the location directly above it on the surface of the Earth is called the epicenter. Sometimes an earthquake has foreshocks. These are smaller earthquakes that happen in the same place as the larger earthquake that follows. Scientists can't tell that an earthquake is a foreshock until the larger earthquake happens. The largest main earthquake is called the main shock. Main shocks always have aftershocks that follow. These are smaller earthquakes that occur afterwards in the same place as the main shock. Depending on the size of the main shock, aftershocks can continue for weeks, months, or even years after the main shock. So what causes an earthquake? And where do they happen? The Earth has four major layers: the inner core, the outer core, the mantle, and the crust. The crust and the top of the mantle make up a thin skin on the surface of our planet known as the lithosphere. But this skin is not all one piece. It is made up of many pieces like a puzzle covering the surface of the Earth. Not only that, but these puzzle pieces keep slowly moving around, sliding past one another and bumping into each other. We call these puzzle pieces tectonic plates, and the edges of the plates are called the plate boundaries. The plate boundaries are made up of many faults, and most of the earthquakes around the world occur on these faults. Since the edges of the plates are rough, they get stuck while the rest of the plate keeps moving. Finally, when the plate has moved far enough, the edges unstick on one of the faults, and there is an earthquake. Most earthquakes occur at plate boundaries. 90% of the earthquakes on Earth are produced at a plate boundary. A convergent boundary is a place where two plates are coming together, creating a subduction zone. Great earthquakes that produce tsunamis occur when rocks fracture in these subduction zones. Transform boundary earthquakes. A transform boundary is like the San Andreas Fault. Produces thousands of earthquakes each year. The mid-ocean ridge forms where two plates are separating. The boundary produces small earthquakes as molten rock moves from the mantle to the surface of the ocean floor. A fault is a fracture or zone of fractures between two blocks of rock. Faults allow the blocks to move relative to each other. This movement may occur rapidly in the form of an earthquake or may occur slowly in the form of creep. Faults may range in length from a few millimeters to thousands of kilometers. Most faults produce repeated displacements over geologic time. During an earthquake, the rock on one side of the fault suddenly slips with respect to the other. The fault surface can be horizontal or vertical with some arbitrary angle in between. Earth scientists use the angle of the fault with respect to the surface, known as the dip, and the direction of slip along the fault to classify faults. Faults which move along the direction of the dip plane are dip-slip faults and described as either normal or reverse, depending on their motion. Faults which move horizontally are known as strike-slip faults and are classified as either right lateral or left lateral. Faults which show both dip-slip and strike-slip motion are known as oblique-slip faults. The following definitions are adapted from the Earth by Press and Seaver. A normal fault. A dip-slip fault in which the block above the fault has moved downward relative to the block below. This type of faulting occurs in response to extension and is often observed in the western United States Basin and Range Province and along oceanic ridge systems. Thrust fault. A deep slip fault in which the upper block above the fault plane moves up and over the lower block. This type of faulting is common in areas of compression, such as regions where one plate is being subducted under another, as in Japan. When the dip angle is shallow, a reverse fault is often described as a thrust fault. Finally, strike slip fault, a fault on which the two blocks slide past one another. The San Andreas Fault is an example of a right lateral fault. Seismograms come in handy for locating earthquakes too, and being able to see the P wave and the S wave is important. P and S waves each shake the ground in different ways as they travel through it. P waves are also faster than S waves, and this fact is what allows us to tell where an earthquake was. To understand how this works, let's compare P and S waves to lightning and thunder. Light travels faster than sound, so during a thunderstorm you will first see the lightning and then you will hear the thunder. If you are close to the lightning, the thunder will boom right after the lightning. But if you are far away from the lightning, you can count several seconds before you hear the thunder. The further you are from the storm, the longer it will take between the lightning and the thunder. P waves are like the lightning, and S waves are like the thunder. The P waves travel faster and shake the ground where you are first. Then the S waves follow and shake the ground also. If you are close to the earthquake, the P and S wave will come one right after the other. But if you are far away, there will be more time between the two. P waves alternately compress and stretch the crustal material parallel to the direction they are propagating. S waves cause the crustal material to move back and forth perpendicular to the direction they are traveling. By looking at the amount of time between the P and S wave on a seismogram recorded on a seismograph, scientists can tell how far away the earthquake was from that location. However, they can't tell in what direction from the seismograph the earthquake was, only how far away it was. If they draw a circle on a map around the station where the radius of the circle is the determined distance to the earthquake, they know the earthquake lies somewhere on that circle, but where? Scientists then use a method called triangulation to determine exactly where the earthquake was. It is called triangulation because a triangle has three sides, and it takes 3 seismographs to locate an earthquake. If you draw a circle on a map around 3 different seismographs where the radius of each is the distance from that station of the earthquake, the intersection of those 3 circles is the epicenter. How do scientists measure earthquakes? There are 2 major scales that describe the size of earthquakes. The first practical scale for measuring earthquakes was developed by geologist Charles Richter at the California Institute of Technology in 1934, and it is the scale that most scientists use today. It is the scale that we see to the left on the slide. The Richter scale has no lower limit and no maximum. It is a logarithmic scale, which means that each 1-point increase on the scale represents a 10-fold increase in the magnitude of the quake. Greater quakes that occur along subduction zones use the moment magnitude scale because it includes the size of the earthquake as well as the size of the seismic waves. This is the scale you see here to the right. The largest earthquake ever recorded was in 1960 in Chile. This earthquake registered 9.5 on the moment magnitude scale. The energy released by an earthquake increases at an even steeper rate, going up by a factor of 32 for each 1-point increase in magnitude. Therefore, a quake with magnitude between 2 and 3 is the lowest normally perceptible to humans. A magnitude 5 quake is considered moderate. Worldwide, there are about 1,500 earthquakes of magnitude 5 or higher every year. An earthquake of magnitude 6 or higher is considered major. The largest earthquakes in history have been of about a magnitude 9. Major earthquakes release far more energy than any man-made explosion. The 1906 San Francisco earthquake, for example, with a magnitude of approximately 8.3, was about 1 million times as powerful as the atomic bomb dropped on Hiroshima. The San Andreas Fault is the major fracture of the Earth's crust in extreme western North America. The fault trends northwestward for more than 1,300 kilometers from the north end of the Gulf of California through Western California, passing seaward into the Pacific Ocean in the vicinity of San Francisco, California. Tectonic movement along the fault has been associated with occasional large earthquakes originating near the surface along its path, including a disastrous quake in San Francisco in 1906, a less serious event there in 1989, and a strong and destructive quake centered in the Los Angeles suburb of Northridge in 1994 that occurred along one of the San Andreas' larger secondary faults. According to the theory of plate tectonics, the San Andreas Fault represents the transformation boundary between two major plates of the Earth's crust, the Northern Pacific Plate to the south and west, and the North American Plate to the north and east. The Northern Pacific Plate is sliding laterally past the North American Plate in a northerly direction, and hence the San Andreas is classified as a strike-slip fault. The movement of the plates relative to each other has been about 1 centimeter per year over geologic time, though the annual rate of the movement has been 4 to 6 centimeters per year since the early 20th century. Parts of the fault line moved as much as 6.4 meters during the 1906 earthquake. On the right of the slide, you can see me standing at one point and pointing to a blue fence post. This is the distance the land moved at Point Reyes, just north of San Francisco during the earthquake in 1906. Below you see another view, a picture taken to the left shortly after that quake. The great majority of California's population lives in the vicinity of the San Andreas Fault. Some cities, towns, housing developments, and roads are actually built on it, and a tunnel of the San Francisco Bay Area Rapid Transit System is bored right through the fault zone. Measures taken to offset the danger from earthquakes include reinforcing roads and bridges to withstand tremors and constructing buildings to absorb seismic shocks. An in-depth view into the San Francisco earthquake in 1906. A powerful earthquake that hit Northern California on April 18, 1906, was one of the worst natural disasters in American history, killing about 3,000 people and destroying most of the city of San Francisco. The Richter scale was not in use at the time of this quake, as it had not been invented, but later estimates put the Richter scale equivalent at a magnitude of between 7.8 and 8.3. Decades of minor quakes led up to the huge earthquake, which occurred at 5:12 in the morning along the San Andreas Fault and lasted about a minute. The epicenter is thought to have been near Daly City, just south of San Francisco proper. Shaking of varying varieties was reported as far south as Los Angeles and well eastward into Nevada. The shaking uprooted trees and buildings, displaced railroad tracks, downed power lines, broke gas lines and water mains, and created huge amounts of rubble all over the city. In all, about 80% of the buildings fell. The huge amount of initial shaking resulted in nearly 400 deaths straight away. A much more deadly consequence of the earthquake, however, was a series of fires that devastated the city and resulted in the majority of the fatalities. Of the city's pre-quake population of 400,000, more than half of that were left homeless. Estimates of deaths as a result of the earthquake and the subsequent fires range up to 3,000. Fires numbered in the several dozen. One particularly well-known fire was set accidentally by a woman who, after the quake, was trying to make breakfast for her family. That fire spread quickly and became known as the ham and eggs fire. Other fires resulted from firefighters using dynamite in an attempt to create fire breaks out of demolished buildings. Not least because the quake had shattered the city's water mains, most fires burned for up to 4 days before finally being extinguished or just burning themselves out. North of San Francisco and Santa Rosa, damage was severe, with much of the downtown turned to rubble. Also hard hit was San Jose, a bit south of San Francisco. Further south along the San Andreas Fault, in Monterey, California, the quake changed the course of the Salinas River, diverting the mouth of the river 10 kilometers south. The disaster resulted in extraordinarily large insurance claims and also a large amount of relief money from all across the world. In the wake of the disaster, Forces of the U.S. Army built thousands of temporary houses in which displaced people lived well into the following year. So why are we talking about the San Francisco earthquake? The San Francisco earthquake of 1906 is one of the most well-known quakes, not only for its death toll and widespread devastation to the city's buildings, but also because of the intense amount of study that has been done in the years since then. Geologists have repeatedly performed intense analysis on the San Andreas Fault and its surrounding faults, poring over the data discovered and recovered after the earthquake and applying the latter innovation of plate tectonics to help understand subsequent quakes elsewhere in California and in the rest of the world. To summarize this video, an introduction to earthquakes. An earthquake is vibration of the earth caused by a sudden release of energy. There are both natural causes and man-made causes of earthquakes. There are three main types of faults: a normal fault, reverse fault, and strike-slip fault. Scientists use P and S waves to measure the size and locate the epicenter of earthquakes. Earthquakes are measured on the Richter scale and the moment magnitude scale. The San Andreas Fault is an example of a strike-slip fault, and the 1906 San Francisco earthquake helps scientists to this day to understand how earthquakes happen.